Section 3. Section 2 we dealt with verifying the trig identity, or those trigonometric identities, so you could prove they exist, prove they actually work. Here we're going to use the same type of process of simplifying, but then we're going to actually figure out what that x needs to be. So solving trig equations, some of them can be very, very simple. When you have something like 2 sine of x equals 1, all you do is divide by 2 and figure out where that equals 1/2 at. Well, that's on the unit circle, so you can get exact answers for this, and you do want exact answers for these, not just decimals. So the thing is, on the unit circle, 1/2 occurs at both pi over 6 and 5 pi over 6. But that's just between 0 and 2 pi. It also occurs after that and before it. Since the default period of sine is 2 pi, the way we end up notating that is to write that you're going to take pi over 6 and add 2n pi to it, and then take 5 pi over 6 and add 2n pi to it. Or if you want 2 pi n, order doesn't really matter. Try to put the 2 first, though, otherwise it can look like n squared. Now, you do need to also add where n is an integer. If you want to shorthand that to n as an element of the integers, that's fine too. But you do need to state that fact. That you're not multiplying with real numbers, you're multiplying with integers. Okay? And because of that repetition, where it goes around and around and around, if you adjust the period, you need to compensate. If it's not 2 pi for the period, you need to compensate for it. But it's not too bad, actually, the algebraic manipulation. You just got to keep track of all the moving parts. Some of them look a little bit strange to start, but actually clean up pretty nicely. If I have sine of x minus square root of 2 is equal to negative sine of x, what would I do? I want to solve for x ultimately. Add sine x to both sides. And also at the same time, I would add the square root of 2 just so it's out of the way. If you want to do this 2 steps, feel free. But when I do that, that's going to give me sine x plus sine x is what? 2 sine of x. Essentially, treat the trig function like the thing you're trying to get by itself first, then get the x by itself. So that's just going to be equal to the square root of 2. Divide by 2. So you get square root of 2 over 2. And then think about on the default graph of sine, or the unit circle. Whereas, what x value will give you square root of 2 over 2? Pi over 4 and I heard 3, I heard 2, I heard 5, all over 4. 3 in the second quadrant. 3 pi over 4. Since it's positive square root of 2 over 2, it has to be in the second and first quadrant for sine. Now each one of those I'm going to add to them. 2 pi n, and then state n as an integer. So yeah, your answer does end up needing to be that long. But at least we're working with numbers. Right, John? Okay. Questions on that one? And honestly, those are the simple types where you can very quickly get to sine of x by itself. Okay? You can also have ones like this. I'm not going to go through the whole thing here, because I do want to make sure we cover everything today. But this one, what would you do to start? Then square root. Add 3, divide by 4 square root. Figure out what sine is equal to that, square root of 3 over 2. Again, it's on the unit circle. We'll skip that one for now. This one mixes quadratic and linear. So I can't just as easily get sine of x by itself. What do I need to do? What's your goal with doing that? Yeah, well, to get it equal to 0. Okay? Because I'm not going to be able to get a complete quadratic with 3 terms, but I can get 2 terms. Then what? How would I factor it? Not the quad program. Yeah, what's your greatest common factor? Sine x. You could, if you wanted to, already u squared minus 2u, and then that makes it very obvious, but you have sine of x in both. Take it out. You're left with sine of x minus 2. Okay? Then what? Yeah, set both equal to 0. So you have sine of x is equal to 0, And sine of x is equal to what? 2. Because sine of x minus 2 equals 0. Add the 2. Now, when is sine of x equal to 0? Pi over 2? Yeah, 2 pi and pi, or if you like, 0 and pi. Right? When is sine of x 2? What? Never. If you did inverse sine of anything bigger or smaller than -1 or +1, what happens? Error, because that sine wave stays between -1 and 1. So this one has no solution. For this one, 0 and pi, how would I actually write that as this thing has to continue forever? Now, think about it for 1 second, though. If I did 0 plus 2 pi n, that works, but you're starting here, then going around. What? Why? Yeah. You could write this as 0 plus 2 pi n and pi plus 2 pi n. The problem is that's not considered simplified because these things repeat at such an often rate, you can actually just add pi every time. So I can actually just start with 0 plus pi n. But do I really need the 0 there? No. Your answer is pi n with what? N is an element of the integers. Or if you just like is an integer. Does that one make sense? If you can simplify things down and isolate it down to writing fewer things about and still cover all those solutions, you do need to do it.
Does that include like writing it out and be considered not simplified?
Writing out what?
Like writing out the words and is.
No, that's fine. That's literally the same thing. I'm just extremely lazy and don't want to write all that. Now, they will have somewhere it's just between 0 and 2 pi. So then you don't need the n as an element of the integers. You just need to come up with every possible solution. For this one, what would I do? I can't because of the 1.
Factor.
Yeah, this is just a straight quadratic trinomial, so I'm going to factor into 2 binomials. So you have 2 sine and sine to multiply to give you 2 sine squared x. What is going to be true about your sines? Both negative. To multiply to give you a positive, add up to be a negative. They're both negative. And since you're multiplying to be 1, that makes it real easy. So, set both equal to 0. The left one, sine of x, is going to be equal to what? 1/2. Move over the 1, divide by 2. This one, sine of x, is going to be equal to 1. So, between 0 and 2 pi, when is sine of x equal to 1/2? Now, 0 to 2 pi, I would stick with pi. But yeah, 30 degrees or pi over 6 is the better answer. And 5 pi over 6. Sine of x is equal to 1 when? Pi over 2. So my 3 answers for this are pi over 6, 5 pi over 6, and pi over 2. Okay? Questions so far? Okay. Now, if you look at the division on the... Oh, wait, no, I'm thinking of section 4. Forget it. Example 5. This one. Say again? What do you mean when you say the same function? Yeah, either make it all secant squared or make it all tangent squared.
This is where 2 points is the question, and 2 pairs on the that doesn't matter with us. But if
Yeah,
they
that's fine.
used what they had up here, it would have been right.
Right,
I
absolutely.
took off partial.
Okay, perfect. That's what I would have done
According
too.
to my judgment.
Yep, that's what I would have done too.
This is the one I don't know what she's doing here.
That's fine.
I don't have.
Okay, so which direction do you want to go with this?
Which is easier?
Now, do you want to replace secant squared with tangent squared or tangent squared with secant squared? Because they don't replace directly.
I don't really like secant.
So let's go tangent. Now, the other thing is on the unit circle, we don't have one of those directly, but we do see tangent more often on the unit circle, right?
Yeah.
So that's why I would replace secant squared with tangent squared. But it doesn't actually replace with tangent squared, it replaces with what? What's secant squared equal to? 1 plus tangent squared. I can tell who has it memorized and who doesn't so far. So 1 plus tangent squared or tangent squared plus 1, either way. Minus 2 tangent squared minus 4. So, now what? Clean it up. Simplify it. Distribute 3. I have 3 tangent squared plus 3 minus 2 tangent squared minus 4. So you get a single tangent squared left, and I'm going to do minus 1 equals 0 first, move over the 1. Yes. So I have tangent squared x, x is equal to 1. Then what? Square root. So tangent of x is equal to what?
1.
Just 1?
Yeah.
Plus or minus
1 and negative 1. Okay? Because of that square root, you have to deal with both the positive and the negative. So, deal with the positive first. When is tangent of x equal to positive 1? Pi over what? Pi over 4. It's when sine and cosine are the same, right? Where else is it equal to 1? 5 pi over 4. Negative 1 would be at 3 pi over 4 because tangent is positive in which two quadrants?
First and third.
First and third. So it's pi over 4, 3 pi over 4 over here, 5 pi over 4 here, 7 pi over 4 here. The problem is, does this ask for between 0 and 2 pi? No, if it did, those would be your 4 answers. Any ideas how I can condense this down while extending it to all solutions? Thinking about the fact that these things are occurring here, 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 and here. Pi over 4 plus a quarter rotation, which is pi over 2n. You still don't know what that is. Haven't I had you for, is this third year or second year I've had you? Second year? Okay.
N is an element of all integers.
N is an element of the integers. Questions on that one? Okay. For this one, find all solutions of the equation on the interval 0 to 2 pi. Sine of x plus 1 is equal to cosine of x. Any ideas where to start with this one?
I would divide by
That'll give you tangent plus secant equals 1.
sounds good to me. It's pretty simplified.
I already have sine and cosine, right?
Yeah.
If I see those two things happening at the same time, I'm going to lean towards Pythagorean. Because that's the only direct connection you have between the two. Now the Pythagorean, though, requires you to have sine squared and cosine squared. So any ideas?
Square root.
So I would square both sides. If I square both sides of this equation, now the one issue with this, whenever you do something like this where you're squaring or square rooting, primarily squaring though, you can end up with extraneous solutions. You can end up with answers that do not work. Okay, so you do need to make sure to check your answers on these. If I square those on the left, I'm going to get plus 2 sine of x plus 1 and cosine squared over here. Then
Cosine squared is 1 minus sine squared.
replace cosine squared with 1 minus sine squared. So now you're at least down to the same thing. Then what?
Move it over inside.
Move all over to the left. So I'm going to subtract 1. Those will go away. and add sine squared. So that'll leave me with what?
2 sine squared plus 2 sine.
2 sine squared plus 2 sine. Take out 2 sine. You're left with sine of x plus 1. Set them both equal to 0. So I have 2 sine of x equals 0, and sine x plus 1 equals 0. So this sine of x is going to be equal to what?
0.
0, just divide by 2. This sine of x is going to be equal to
Negative 1.
-1. Okay? When is sine of x 0?
0.
0 and pi. When is sine of x negative 1? Three pi over 2. Right? So, but it does say between 0 and 2 pi, so you do get your answers in there. So I don't need the plus, or the n is element, or the plus 2 pi n, or any of that stuff. But I do need to check these answers. Because if I plug in 0, what's sine of 0? Sine of 0 degrees is 0. Plus 1 is 1. What's cosine of 0? 1. 1 equals 1, it works. If I plug in pi, what's sine of pi? 0. Plus 1 is 1. What's cosine of pi? Is 1 equal to negative 1?
No, but then cosine.
No, we squared it, which is why that causes an issue. Because the squaring makes that positive and negative go away. Well, the negative is an issue because negative 1 doesn't equal positive 1, right? Their squareds are equal, but that's not what the original problem says. 3 pi over 2 works or doesn't work? Well, I thought you just said one of the... Sine of 3 pi over 2 is what?
0.
1 negative 1.
Negative 1. Negative 1 plus 1 is? 0. Cosine of 3 pi over 2?
0.
0. 0 equals 0. So these are your two solutions.
What about 2 pi? Wait, I'm just kidding.
Okay.
The parentheses, because I got it.
Okay. Let's do another one.
Okay.
Find all the solutions to this. What would I do first? Yeah, add the square root of 3 over 2 to both sides, giving you sine 2x is equal to square root of 3 over 2. Then what? Now,
You don't.
if that said sine of theta instead, what would you do? Find it on the unit circle. The only difference is instead of saying theta, it says 2x. So I'm going to have 2x equals a solution. Instead of having x equals, I have 2x equals what?
3 dividing answer by 2.
Yeah. So square root of 3 over 2, when does that happen for sine?
60 degrees. I would 3.
Pi over 3. And how often does that reoccur?
Every 60 degrees.
Every what?
60 degrees. And then it's
For sine and cosine, unless you're talking about an oddball one like pi over 2 or 0 or something like that, it's just going to be plus 2 pi n to start. Because the period of the function is 2 pi n. Okay? Tangent will be plus pi n as default. Where's the other one at for sine? 2 pi over 3. Plus 2 pi n. But each one of those things, you're going to need to do what? Divide by 2 or multiply by a half. When I do that, what's going to happen to the pi over 3? Pi over 6. What's going to happen to the 2 pi n? Becomes pi n. What do you get? Pi over 3 plus pi n. And then that thing. Okay? And the idea is because you're having a period change here, it's shrinking by half. Because you're multiplying by 2 inside of the sign here, right? So that means things are going to occur more often, and this compensates for that. Okay. do a couple more, and then we'll be done. Find all solutions to tangent of x over 2 minus 1 equals 0. First up, add 1. Then? Yep. Where does tangent equal 1 at? Pi over 4. And how often does that repeat? Every pi or every pi n? Okay. Now it also occurs in the third quadrant, but adding pi n hits that one, so you don't need to worry about it. But then x over 2 means I have to do what? Multiply by 2. So that's going to give me? Plus 2 pi n. Okay. One more. 4 tangent squared x plus 5 tangent of x equals 6. Subtract the 6. Then factor it. That's going to factor into, there's more than 2 ways to do it, but yes. There's 2 ways to do the first number. You want to do 4 tangent and 1 tangent, or 2 tangent and 2 tangents? 2 and 2? Two tangent and 2 tangent. Now, you need to multiply to be a negative, add up to be a positive, so what's going to be true about your signs? It'll be what? 1 positive and 1 negative. Then you're trying to multiply to get those last 2 to get negative 6. What do you want to do? It's not that many choices, guys.
Well, it's 2 and 3 or 6 and 1.
Okay.
There are 2 choices. Let's go 2 and 3 and see what happens. Plays a lot.
Problem is there, that's going to give you positive 4 minus 6. Does that give me 5?
No.
No.
So that means we try 6 and 1.
Okay.
We also try 12.
What's 6 and 1 going to give me? 12 minus 2? It's not quite 5.
You don't do the 2 tangent, you do the 4 and 1.
You do the 4 and the 1. So if I do 4 and 1, that's 6 minus 4. That's not going to work. If I flip it, it's going to give me 24, so that's not going to work. 2 and 3. That's 2 minus 3 and 2. That's 3 minus 8 gives me negative 5, which is close, but the signs are off, so flip them. You guys pretty much took the longest time possible doing that one.
Help.
Now, we're still not done. That was just factoring. Now what?
Oh, that should have been the end of the problem right there.
Set of h equal to 0. So on the left, I'm going to get tangent of x is equal to what?
Negative.
3/4. Over here, I'm going to get tangent of x is equal to? Negative 2. Now the nice thing, tangent goes negative infinity to infinity, so you can have any value there. The bad news is, are these on the unit circle? Like known values? No.
No.
So you got to get a little bit creative to get an exact answer for this. X is going to be the arctangent of 3/4. Or if you prefer, x could be the inverse tangent of negative 2. But to each of those, I would have to add what? Because this one's all solutions. What? Pi n. Default period for tangent is pi, so add pi n, and lastly,
The element thing.
yep, n is an integer. And yes, the answer is that long, and there is no good way to shorten it. Questions?
Yeah, first question.
Yes.
Oh.
Who's about to go? Second question. Would you like us to simplify that, or is that?
It doesn't simplify. That's the exact answer.
Like, would you like to actually go through and give me like an estimated?
No.
Okay.
Okay, so, like I said, I'm not going to be here the next 2 days. Make use of the time. These problems are easy to get lost on. If you do not practice them, this test will hurt significantly.
I think it's gonna hurt either way.